Okay, this is a short presentation to explain the use of the lab power supply that we have at our at AME's electronic workshop. All right, so why power supply? The reason we use a power supply is, first of all, it consistently generates constant voltage. It will allow for current monitoring about the circuit that you are working on. You don't need to worry about battery holders, and also costs lower to use because you don't need to keep replacing batteries. Okay, what do we mean by constant voltage? Depending on the circuit that you are working on, when you are using a battery, and for whatever reason, or if the circuit that you are working on requires a significant amount of current, when you are using a battery, also depending on the size of the battery, larger batteries have larger capacities. Smaller batteries tend to run down, faster. So essentially, as you use the battery voltage is not going to stay the same. It's going to continue to decline. Whereas when you use a power supply, because it gets its power from the power mains, from the facility supply, the voltage remains constant. That is very useful. Second is current monitoring. Current monitoring is very important, especially when working on experimental circuits, because obviously you are in the experimental stage. You don't know exactly how the circuit is going to work. You may have to tune it up a couple of places. You may have to make changes on your circuit. So basically, on experimental work, you need to monitor your circuit closely. What that means is the current consumption of your circuit is a very good, important information, because in the process of building the circuit, while you are interconnecting the components, you are moving around the circuit, you are using different tools to do either tests or pulling components, inserting components. It is not impossible to inadvertently create a short circuit. A short circuit is current flowing not through the proper channels that it is designed to flow through, but you are creating like a short, and a large amount of current is going to be drawn. So when that happens, some devices can be damaged, permanently. Some components in your circuit. And depending on what you are working on, you can create small fire. Okay, you can end up smoking a couple of the components. So that's why current monitoring is important. And in addition to just from working on the top of the circuit, sometimes you are concentrating on the work and you're not paying attention to what is on your desk. There may be several pieces of metals, screwdrivers, the different kinds of conductors. And if you are working on a proto board where usually the connections are made in the back using soldering, and if you by accident place that board while it is being powered and while the circuit is working, if you inadvertently place it on top of any kind of metal that is on your desk, you are looking on top of the components, but in the back where the connections are being made are being shorted by some piece of metal that is already on your desk. So these are things that can happen. So when this happens, if you are using a power supply, you will see the current going, much higher than what the circuit was drawing normally. And also the other good thing is because, as you will see in subsequent slides, one of the things that you are going to do in setting up the power supply is setting the current value. So because you have set the current value to what is normally required for the circuit, if a short happens and the circuit attempts to draw a large amount of current, the power supply will not make that extra current available. It would saturate at the setting that you set it on. So meaning your circuit will not be damaged. Whereas if you are using a battery, all the current available within the battery is going to be dumped, and your circuit can be damaged. So that's what's meant by current monitoring. So that is a very, very useful tool for monitoring the health of the circuit that you are working on. All right, okay. Next is when you are using a power supply, you don't have to worry about battery holders depending on what kind of battery you are using, whether it's AA, AAA, 9 volts, or D size. When you are using batteries, you have to find some sort of a battery holder depending for the number of batteries. If you are using 2 batteries, you need one kind of battery holder. If you are using 4 batteries, you need a different kind of battery holder. So you have to find the proper battery holder for the voltage and battery type and size that you are using. So, if you are using a power supply, that is another thing that you don't have to worry about. The other thing is cost. If you are using a battery, as I said, depending on what the consumption level of the circuit that you are working on is, the battery is gonna die, so you're gonna have to keep replacing it. So that is additional cost. If you are using a power supply, that's another thing that you don't have to worry about. Okay, hopefully we have convinced you the importance and usefulness of a power supply, and hopefully that's the case. So we'll move on to show you how easy it is to use the power supply that we have in our lab. This is the power supply we have. It's a BK Precision 1670A. And in the next slide, we'll see an annotated version. So what we have here is, it shows the 2 displays, the voltage display on the top left corner. It's an LCD display. Okay, when it turns on, you will see the value there. Next to it is a current display. That's what we discussed earlier about monitoring the current. Next to the right, you see the voltage adjustment knob labeled voltage adjust. Below it is the current adjustment knob. Below that are the power supply leads. Those are the wires that you are going to be connecting to your circuit to power the circuit. And then at the bottom left corner, you see the power switch to turn the power supply on and off. And at the bottom middle of the power supply, we have additional outputs. They are auxiliary outputs. The voltage and current is not adjustable. So this power supply has 2 additional outputs for the most commonly needed voltage levels: 5 volt, the ubiquitous 5 volts, and 12 volts. And of course, the current is limited to, as you can see on both of them, 0.5 amps. So we generally don't use those. That's why we don't supply the leads, the connecting wires, because the adjustable one can provide all the voltages that you need with the additional convenience of adjusting the current. So the common settings for voltage, for example, although the Our supply is capable of producing from 0 to 30 volts, and in terms of current, from 0 to 3 amps. 3 amps means 3000 milliamps. Okay. Okay. So, but for most devices, for most circuits, especially for things that we work in our department and in our lab, the commonly needed voltages are 12 volt, 9 volt, 5 volt, and 5 volt is of course the most common. And then 3.3 volts is for the newer development boards like the Tinsy and many other ones. The other thing is you need to, would be good if you have some idea of the current requirement of your circuit, so that when you adjust the power supply, you will set the current value to slightly larger than what your circuit requires. For many of the things that we, I would say 80–90% of the work that we do in our lab, the 1 amp is more than enough. So on this presentation, we will show how to set the current to 1 amps. All right, here we go. We start by turning the power supply on, but before we do that, we will turn the voltage control knob all the way counterclockwise, okay, counterclockwise to the minimum value, so that the voltage is going to be 0. And then the current knob, we are going to put it at the 9 o'clock position, or it should be pointing left or to the west, okay? And then after you do this, you turn the power supply on. Next is setting the voltage. While you are monitoring the voltage display that we mentioned earlier, you slowly start turning the voltage control knob clockwise, and you will see the voltage increasing, and you continue doing that until you get to the voltage that you are interested in, and then you stop. It's just that simple. And here is a picture that shows that. As you can see, the voltage display shows 5.0 volts, and you see the finger turning the voltage control knob. And there is a more detailed video on the next slide. And as you can see, if you look at the voltage display, it's increasing. That's because he is slowly turning it. So 4, 5. So if you go past the value that you are looking for, you can always go back, and then you can go back and forth, you know, on the knob until you get it to the point or to the value of the voltage that you are interested in. So as you can see, it has reached 5 volts. In this case, we are adjusting it to produce 5 volts, and it has reached 5 volts. Next is setting the current. So after the voltage is set, you are now ready to adjust the current. And to do this, what you are going to do is you are going to short the power supply leads. What that means is you are going to connect them together, and then you start turning the current control knob until the current display shows the value that you want to adjust the current to. Now, shorting the leads is just a quick thing that we do to adjust the current. It's not, you should immediately disconnect them. Besides, they need to be disconnected to be connected to your circuit anyway. But the point I'm trying to make here is, shorting power supply leads is, in our case, our power supply has a current protective circuitry inside that is going to prevent damage to the power supply. But not all power supplies are designed like that, and you should know that shorting the power supply leads is not good practice, especially to leave it permanently. In this case, it is required to make the adjustment of the current, and we are just doing that briefly for 10 seconds, 15 seconds to 20 seconds, worst case scenario. And here is a picture that shows the value of the current display, showing 1.05 amps, and the user is adjusting the current by turning the current control knob. And also you can see that the negative and positive leads of the power supply, the red and the black, are connected together to make the adjustment on the current. And here is a short video that shows this. As you can see, all right, so you short the power supply leads, and then you go and start turning the current. You see the current display is going up, 0.4, 0.5, 0.6, 0.8, 1.00. So that means 1 amps. When you short the power supply leads, the voltage that you set earlier, which was 5 volts, is gonna go down to 0. This is not a problem. That's how power supplies work. It is because you are shorting it. It's part of the protection circuit in the power supply that turns the voltage all the way down when you short it. Okay, so don't pay attention to that. Just pay attention to the current, and as soon as you disconnect the leads, the voltage is going to go back to the setting that you accomplished in the earlier step. All right, so this is just an extra note. When you connect the power supply leads together to adjust the current, the voltage setting will go down close to 0. This is normal. You will go back to the setting you selected as soon as you disconnect the leads to use them with your circuit. So you are now ready to use the power supply, and happy making! This presentation is available if you need to review it and play it as many times as you want at the Wikispaces address for the lab given below at ame-elab.wikispaces.asu.edu under resources. Okay, so it is available for you to view it as many times as you want. Thank you for watching.